Good morning. I will now continue with my theme of how to make a simple mechanical enclosure for your electronics product. So, if I see here, I will show you two products here. If you see, this is a very ubiquitous power supply. We are all familiar with this because we need power. So, if you see inside a power supply, first of all it has a cover, and very unavoidable thing is this heavy transformer. The moment we have all these parts, our natural selection is probably about why do not we use a metal, because it has to take the weight. Now, if we go out and look at another power supply, this is taken from a computer. There are not many heavy components here, there are a lot of components anyway. You can see that there is a big PCB, then there is an inductor, there are some power dissipating devices, and something we come to like and hate are these bunches of connectors. They are both bad and good. If you use it in an unwanted place, it will create problems. If you use it in a correctly applied place, they are a convenience. You can always disconnect and connect and so on. And then this also incidentally is made out of sheet metal only, except it is thin, extremely thin, and it is made in a very complicated way. A lot of embossings are there, a lot of openings are there, and it does all its functions. Now, I will start with the, what do you call, my PowerPoint. Why should we have sheet metal at all for an enclosure? So, the first point, why is it useful, is it is easy and available. Though we keep talking about various things like why cars should not be made of light materials and all that. If you see, the main body of the car is still made out of a specially treated steel sheet. Occasionally you have aluminum things, but the main panels and all are all sheet steel. But then if you notice the bumper in the front and back, they have all been now replaced with engineering plastics, because over the course of years they have found out probably it is much more. A heavy dented fender is not very good. First of all, it cannot absorb all the energy, it will transfer the energy and probably get us into a different situation. Instead, everything has been now replaced with variants of probably nylon or some new high impact polyester materials with various types of filling inside. So, down if you give here, main important thing is, if you have to make a prototype, most small workshops are able to make something 300 mm is equivalent to about a foot, this much of a enclosure. You can enclose anything you want into that, and very important is it can be painted and graphics can be added. Very easy to take a flat sheet metal and then maybe you can spray paint it, or you can print graphics onto it, like as in a front panel, like as in a rear panel, in which we give clear indications of what each of the items are doing. And main problem is not, the advantage of is, in the unlikely case there is some damage or some other additional work has to be done, it can always be redone. Coming back to my this thing here, say let us say in the beginning when we started with a simple power supply, okay. And the core of it is we have a transformer. Why it has been made this way is, it is probably part of some rack equipment or something, where this directly gives an AC output, and this AC output is treated to do various way. So, this is basically a very simple 230 volts to some wanted AC input thing. Let us say we wanted to change something, we just wanted to add an indicator to see if the mains is on. Similarly, we would like to see if the current is being exceeded. If you have a series element and then in case the current is there, we can even monitor the output, saying if the light is on, that means some current is flowing. If it is very bright, probably it is about to trip. In contrast, While that is a single what do you call use single part thing, you see this stuff we see everywhere. You have seen this, no? Too many connectors, too many voltages, everything. Fortunately, no, we have a bunch of wires here. This bunch of wires takes us to all the outputs you want. So many outputs, every voltage, current, floating, independent. So if you were to look at the outside, you will get tremendous amount of things. This is where I want to tell you, it being flat, you can always add this decal or a sticker on top of it. It shows in this case, no, that it gives you 5 volts 20 amps, and then there is a 3.3 volt 15 amps. That you cannot achieve easily using that big linear power supply. Why I am saying this is, if you see the way the whole thing has been made, it does not add much to the weight, and you can repair it. You can add voltages, remove voltages, make it as big as possible. Next slide will take us to why we will not be able to use this in all conditions. First is, it is still metal. So, metal has one thing is that its conductivity is a little high. Shortcuts can create short circuits. I thought it is a fantastic pun on it, but the idea being, in case you do not use things like a proper grommet. See here, we have a grommet here. In case you do not use that grommet, we end up with it creating a short circuit. Similarly, if the inside electronics is not properly placed on a standoff, if you do not have proper insulated standoffs where these items are standing there, if we do not have them properly, chances of it short circuit can be done. See how they have managed it. To avoid it, what they have done is they have made a small embossing here. They have made an embossing here. They have used a tool to press the material inside, and then they have put a screw here, and then underneath that there is even a washer which ensures that the strength is not compromised, and so is the electrical insulation property. Both are not compromised, because the one that is holding is still the strong metal fastener. The one that needs isolation is a small washer, all that is required, thickness is less. Now if you go further, finish depends on detailed drawings and time. In this case, finishing is about making a corrosion resistant coating on the other thing, and another thing is the type of how well it looks. It looks well because you see we have a fan here. The fan has 4 mounting holes. You have 4 mounting holes for the fan, and then there is an opening here. The way everything has been calculated and the way everything has been punched, if you have sufficient detail, we have a neat presentable product which does not crumble in your hands. It is what do you call, still fragile in some parts, still there is a way you can hold it and you can mount it inside. Coming back to my this thing, a little bit of brain work is needed to at least explain what is needed to your skilled helpful friends. Here this was targeted at engineering what do you call graduate students who are very good in their basic focus of electronics, but then they are not expected to make all these drawings and so on, just like I am sure some of you who are following it. So you should know a little bit about mechanical, saying how do you term a particular thing. There is something which is lugging, which is called, there is something blanking, and then you also have a drill and tap and so on. If you can convey all this in a drawing, eventually it can be fabricated. So I start with a very horrible caution note here. A not so great way start with a rectangular PCB, because we have a PCB layout electronic tool which is sitting, design automation tool which is sitting in our computer. So what the design automation tool does is, it will make you saying make a hole here, that is a good point to start, make one more hole here, make 4 holes in the corners. Good, no? This is how you design an island, saying now make sure that thing does not come here and all that. While for making a PCB, for checking outside, is not a very great way to start, because soon you will find out that there is no place and you end up with making things which are likely to cause problems. So, the next slide will explain to me saying overall think about how your product is. It has a form. Sometimes the word form factor is used, which actually means something else, but we understand. Get familiar with, in the MIT courseware, Rhode Island School of Design, Mr. Cressy has given a beautiful presentation saying how to start. So, familiar with the approach. This will help you maintain overall proportions, aided in the appropriate semantics of your product. So, if you are to make something, it will convey some ideas, just like your words have certain ideas. Some of them are attractive, what do you call, pleasant to hear, some of them are very harsh. So, if somebody will to call you a rascal or an idiot, it has a different meaning. Same thing it is with products. Some products have this feeling of being threatening if you have the sharp edges and so on. So, the product semiotics, what the meanings the products contain, will also make a lot of sense if you have some models which are made with it. An acceptable start is to have competing solutions for your product on hand. Sketches and 3D models ready. Most important seems to be, I kept on insisting on that. In fact, all designers, they seem to work on with sketches and sketches. And now that we work in 3D, obviously you need to make 3D representations of your ideas, what you have in hand. So, we have here, I told you, I have shown you a phone, and then we have this beautiful mouse. Seen this, no? A mouse. By looking at it itself, you have a little bit of confidence. So, first time you would have wondered, no, should the tail be pointing away from you or not? And then we have this beautiful wireless device. If you have a concept how it's expected to look, you can make a neat compact thing. One thing, have you noticed, the antenna comes out on the top. So, it is that this connection to the collar mic. And then one thing which should have not, often you do not come across is, there is a beautiful device which holds the thing. There is a knurled thread there, and then you can couple things. And then something related a little to it is a display here, which shows you various features. So, we have a display, we have a connector, we have something to do with the RFID, RF antenna, and then we have other things which in the normal course one should not touch. This is a power on off button. By some bad luck, the power on off and reset button ended up on the front panel of the ubiquitous personal computer. So, an OC person like me, either out of ignorance or out of malice, I go and press the reset button on my friend's computer, and remember that friend does not have the watchdog timer which I have thought about it, that I have shown you in the earlier thing. Now, all the work is lost. So, here if you see the way they have made it, they have made it flush, so that accidentally nothing gets pressed. When I was trying to wear it and all, it does not get pressed. In contrast, the other thing, there is a big mute button here. The mute button has something which is outside. So, even if I am without looking at it, I just go and press it, I can mute it. And then we also have some other buttons here. So, obviously this is a well thought out product. So, it is a 6-sided parallelepiped. The back portion contains this clip, so that I can wear it either in a pocket or on my hip. And then one face of it has some volume gain control. Instead of making it rotary, they have made switch. One side has the on off switch and all that. This switch is the front side, gives a display of various parameters which is probably programmable, and on the top we have this relatively very simple product, and it has a form which is uncluttered and simple, but still a lot of thought has gone into it. So, where we start, have an estimate of the area required for your circuit. In the case, this is referring to the printed wiring board or printed circuit board, must have some idea of what it is. Then a block schematic is divided logically into manageable elements. So, let us say your printed wiring board has some digital section, then there is a analog. In analog you may have low level high gain sections, and then you have a RF section. Similarly, case a power supply, you may have an input high voltage section and an output section, and then some interconnection section. So, the block schematic typically allows you into logically cut your thing into manageable sections. Then we have a detailed schematic of where and how your system can be slit. Example, power supply, diodes, regulator and power on LED. So, it is possible for you now to take a chance of it. Slowly we are coming into relatively complicated thing. We have this interface details, decide on the electrical I/O interface details. Some of them are, if it is a question of a control panel, some of them are displays, some of them are where we have to take action, that is the controls about it. Then how do you decide on the wires and the type of connectors, and then if it is a wireless, you end up with antennas. So, if you take our modern phone, it is getting how do you say, threateningly complicated. It has 6 antennas of one size or the other. This ordinary phone, it has a very large number of antennas, and all the time they are adding something to it. Originally it just had a 900, 800, 900, 1800 megahertz simple GSM antenna. Then we have ended up anything more. We have now NFC, we have Bluetooth, we have various other types of wireless. Suddenly power charging has come. So, there is a dock, you place it on that, and then by eliminating this power connector, your life can be extended, but all of it is still not easy. Something a little related to this is the machine human interface details. What does the machine tell you and what you tell the machine? So, we have displays, we have keys, we have microphones, we have speakers, we have jacks, IR receivers, etc. So, what is a very simple remote control for a TV or any of these things still has tremendous amount of thought behind it. Very important thing is get the details of each of these items. You just cannot randomly say a connector will come here. So, now I want you to have a look at this my power supply. I think all of you remember with this cutout. It is very simple. It looks like obviously there is some rectangular object with 2 screws. Several ways of mounting it. One of them is you can mount the what you call I think the male part of it. No, the pin assembly goes here, and at the back you continue with the soldering, input and output and try to do. There are 2 wires which have been cut off here. Looks okay, is it not? Because replacing from the outside is easy. All you have to do is remove the screws and pull it out. But then electrical side, it is not that simple, because when you want to assemble this PCB, you are anyway assembling all this wiring harness onto the PCB. When you are assembling all the wiring harness, it is logical that you have a connector which sits from behind instead of sitting from the front. Now, if you go back to your PC and see these power supplies, no, that has all the provisions. If you want, you can mount it from here. Alternatively, you can put it from behind. And the moment you put it from behind, we end up with this detail saying, we have a tapped screw here. We can't use the tap screw anymore. This threaded portion should go into the connector, or at the back of the connector we need to have the thread, so that you can put a screw here. But then if you put it in the front, we have the advantage that we need to, this is called a plunge and tap. It is very easy for us to just make a funnel like thing and tap it. Very simple. Somebody has to take this decision. Now how do we get over that problem, which is better? This is where I see, depending on, do we actually do a repair on this? It is unlikely we will do a repair. So in case something fails, we take a higher rating thing and just push it inside. So it is not a big issue. It's logical that we keep it from outside, so it's easy for us to put it and continue with all the work. Alternately, we put it from the inside because of the total manufacturing cost is, the assembly cost of this device is small. So somebody needs to gather all these details before we end up in a problem. No detail, no product. For every little small item, you need to gather the detail about it. Something very much related to, again, or part of it is the large volume items, starting from PSC component, displays, connectors, all the way to the small wire. Every detail is better you have it with you. So most successful engineering products, they are successful because of the product detailing. And then again, in detailing, both issues are there. One is the mechanical detailing and how to fabricate it. Another is the detailing about the design, the appearance of the thing. From outside, how neat does it look, and then is it manageable, easy to use, and all that. So we have all this stuff now, wire harnesses, cable stays, grommets. We have all this stuff. Just now I showed it to you. Not an easy life for all of them. Start a layout. Arrange all the components in relation to each other. To start with, look at what is likely to be visible outside. This is what I showed you, a sample of the transmitter which goes with the wireless mic here. Arrange all the important features like the display elements where they would appear on the enclosure. Now going back about 3 lectures back, I asked you to imagine one any handheld device which is likely to have 2 probes, likely to have a display, and then how will you keep it on the table? Is it at an angle? And then in case you want to hang it around your neck, can we still use it? And are there small things that are required? Good, a very good start. Arrange the control panel elements like knobs and keys as per our original concept. This has been made a few years back. These days, luckily for us, you can configure things on a mass produced product, but however still individual products are not that easy to have them reliable and make it work. So if you have to have a power switch, if you have to have some sort of high voltage or high current connections, you still need to have the keys, knobs, all this is reality. And it should also look presentable and make sure that the operator does not do an error. If you remove the all old components, the new ones, now you have a provision of making them very, very presentable. And if you take a place like even a control panel for a CNC machine, one part of it, a small section of it still has that old what looks like a jogging knob and a shuttle, and the remaining display part is there, and several other things are all programmable keys. So we have this connectors, no? They are a blessing and a nuisance. Blessing is you can detach anything into other parts and replace things. I have shown you about the power supply. In case the power supply fails, you just need to replace another power supply which occupies about the same area. In case you need other voltages or things have changed, you can continue to use the old PSU cabinet and get power supplies which can give you lower and lower voltages. So we have a 3.3 volts supply, which is very good. And then if you see, some of the connectors need to be accessible during operation, but some of them are only needed at the start of the deployment. That is, when you install the equipment, You can adjust the various levels, maximum and minimum, and one of the well known thing is the voltages. So, do you like to monitor the voltage, and then once it is done you seal it, you do not need to do it. Only in the case of when a failure occurs you can go and attend to that. Having started from the outside, we slowly go into the internal hardware. Make space for the cable and wiring inside the equipment. Ensure that all the elements are connected as per the schematic. Make a best fit guess as to how, see I found a devil here, how well things are likely to stay together. I mean just again a little small pun. If there is something that should be replaceable, it should be probably isolated. A replaceable object can be isolated, or something called test field components are there. You try things in the field and then try to keep things, optimize it for that particular setup. After that you stop. Let us say you have a video projector which is being fitted in your classroom or at home. You do not need to keep on fiddling with all the various things like the focus, and then you need not to fiddle with whether do I fit the height or do I fit the width or is an aspect ratio. Maybe a little about the ambient illumination is all that is required. All this can be done and things will move on smoothly. When the two things can fail in that, one of these that electronics which drives the display, actually it is a shutter like thing, and the other one is the main power supply with a lamp. So, is there a way I can replace these things? As I expect, no, things slowly come better and better. For a given wattage you can get more lumens, or for a given lumens, as technology progresses, probably less voltage is required to drive that, that is related to current and so on. So, if you have a schematic, it is always for us to a best fit guess. Nobody can optimize everything in the what you call first time. I think we do not know, still they are debating how long it has taken us to evolve to this condition. It has taken time. Mechanical hardware that can hold and fix the elements. So, this is where I was talking to you about. Do you require a screw, do you require a standoff, and do you require a grommet, and then do you need a cheese head screw, or would you need a countersunk screw? And then in case cheese head is a must, how do you hide the top portion and all that? And then something equally important is how is the interconnecting device held in place. It is very much possible for us, you keep everything such that proper snaps are available, push it into the snaps and then close the lid, and then there will be a single screw holding both the parts together. So, we have all these things, what are the sizes of the fasteners? After, if you do not decide, if you do not have information with you up front, we try to do firefighting. Sir, this screw head is looking big, can I get a smaller screw head? I mean that of course that is what a student would ask. What a designer would do is now he will try to search around for it. If we have a library of all these components a priori, we can always work with these things and make things better and better together.